In the previous video, we calculated P bar and Q bar. So now what we're going to do is move on to the next page, page 20, and go ahead and calculate our test statistic. So as you can see, I can get the test statistic formula from the flowchart. We're comparing two samples that are a proportion. So we did this section already, the P bar stuff. Here's the formula for the test statistic. And it's really it's really important that you write down the formula correctly. It's P1 bar minus P2 bar. So you subtract the two samples values from each other. And then down below we have a really big square root, which is P bar Q bar over N1 plus P bar Q bar over N2. And so you notice that up here it's P1 hat and P2 hat. Those are going to be the two proportion values that we found. On the bottom it's P bar and Q bar, which are the pooled values that we found. And so you have to put the values in the right place. So if we were plugging this in, and I'm going to write it nice and big, if we were plugging this in, it would be our first sample value, which was 0.109398, minus our second proportion value, which was 0.135897, 436. And down below we have a very, very big square root, which is going to be 0.113590264 times Q bar, which is 0.8864, 0.9736. And we take that entire amount, P bar times Q bar, and we divide it by starting with our first sample size, which was 2075. Then we have a little plus sign, and we do those same numbers again. And this time you divide by the other sample size, which was 390. So you can see that this takes quite a bit of work, unfortunately. This is probably the longest formula out of all of them in order to find our test statistic. And so I do not recommend you try doing this all in your calculator all at once unless you're really, really careful. It's better to maybe do this thing first in your calculator, write down that number, then add it to this thing, calculate this thing, write down that number, add those two numbers, then take the square root of that number, because remember the square root has to be the square root of all of this, and then maybe do this minus this and then this divided by this. So lots of chances to make a mistake here. If you want to try to put the whole thing in your calculator all at once, here's how you would do it. Notice I'm starting with a parenthesis for my numerator. 109398 minus 0.135897436, and then I close the parenthesis, divided by, I'm going to put a parenthesis here, square root, and now I'm going to do another parenthesis because we need to take the square root of the entire thing. And in fact, because of that, I don't think I need this parenthesis anymore. So it's the square root of 0.113590264 times 0.8864099736 divided by 2075 plus, and then you type in the numbers again, and there you go. And we get an answer of negative 1.511, which is the correct answer. This is the correct answer right here. So the test statistic is z is equal to negative 1.51 if you round it to just the hundredths decimal place, which is what the computer wanted you to do. So there you go. We got our test statistic and we rounded it, and notice that it's negative. That's okay because we have our first sample being smaller than our second sample, so it's okay that we get a negative test statistic. In the next video, I'm going to show you how we find the p-value, but before we do that, let's go ahead and compare it to the critical value. Notice that because we were doing a less than sign here, it means that we're only doing a one-tail test. So our confidence level was 90% because alpha was 0.10, which you can see right here. Alpha level of 0.10, which is a 90% confidence level. So if we come over here and we do 90% one tail, we get a critical value of 1.282. So you can see that the absolute value of our test statistic is larger than our critical value. So think about what that means, and in the next video we will do the p-value.